Dear students, under the topic Method of Variation of Parameters in Ordinary Partial Differential Equation, we are going to solve problem 3. Already we have completed problem 1 and 2, so kindly follow those lectures before going through this problem. Now here the question is solve d square y by dx square plus y is equal to cosecant x using the method of variation of parameters. First of all, we shall write the given equation in the normal form, that is, we know that d square y by dx square is represented as y double dash, and then plus we have a y here is equal to cosecant x is given on the right. So whatever is there on the right, we take it to be capital X, which is a function of small x. So capital X is equal to cosecant x. So after choosing capital X, we have to write the auxiliary equation for the given ordinary differential equation. The auxiliary equation of the given ordinary differential equation is, here we have my double dash, so it should be m square, plus here we have y, so it should be 1, is equal to 0. So this is the auxiliary equation. Now we have to find the roots of this auxiliary equation. So from this we get m square to be equal to, taking this plus 1 to the right, we have negative 1. So therefore the value of m is equal to plus or minus square root of minus 1, and that is equal to plus or minus, we know that the square root of minus 1 is I. So therefore the value of m is equal to plus or minus I, which is an imaginary number whose real part is 0. So the imaginary number is alpha plus or minus I beta. Now if you compare with that, we see that the real part is 0 over here. So alpha is equal to 0. And the value of beta is the 1 over here. So the value of beta is equal to 1. Now using this, we have to write the complementary function. So whenever the imaginary roots occur, the complementary function is given by, so it is given by e to the power alpha x multiplied with a cos beta x plus b sin beta x. Now since the value of alpha is 0, e raised to the power 0 will become 1. So this will become 1. And since the value of beta is equal to 1, we get the complementary function to be equal to, this becomes 1, and here a cos, the value of beta is 1, and so we get cos x plus b sin, and again here beta is 1, so we get x over here. So it is a cos x plus b sin x. So this is the complementary function. The next step is we have to compare this complementary function with a f1 plus b f2. This is as per the method of variation of parameters. If you follow the first two problems that we have completed, you will understand how I have written this. So this is by the procedure of method of variation of parameters. Now comparing these two, what is the value of f1? f1 is equal to cos x, and the value of f2 is equal to sin x. So we shall take and write that. So f1 is equal to cos x and f2 is equal to sin x. The next step is we have to differentiate these two functions with respect to x. So f1 dash will be equal to minus sin x, because the differentiation of cos x is minus sin x, and f2 dash is equal to cos x, because the differentiation of sin x is equal to cos x. Now we have obtained f1 dash and f2 dash. The next step is we have to find the Wronskian W. So the value of W is equal to f1 f2 dash minus f2 f1 dash. Now we shall substitute these values. So that will be equal to, what is f1? f1 is cos x. So cos x multiplied with f2 dash. What is f2 dash? It is also cos x. And then minus, what is f2? f2 is sin x. And f1 dash, what is f1 dash? Minus sin x. So this has to be multiplied with minus sin x. Now this will be further equal to, what is cos x into cos x? It is cos squared x, and minus into this minus becomes plus, and sin x into sin x is sin squared x. We know that cos squared x plus sin squared x is equal to 1. This is by the trigonometric identity. And hence we obtain the value of w to be equal to 1. Therefore, we have evaluated the value of w. Why did we evaluate this value of w? Because we want to find capital P and capital Q, where we have to substitute this value of w. So what is capital P and capital Q? It is given by the formula. So here the formula of P is negative integral f2 by w multiplied with x dx, and Q is equal to integral f1 by w multiplied with x dx. So this I have taken from the procedure of method of variation of parameters. So now we shall substitute this w, f2, f1, x, all these in this and evaluate capital P and capital Q. So let us do that now. So I have taken and written capital P, which is equal to minus integral f2 by w multiplied with x and dx. And now we shall substitute each of the values here. So this will be equal to negative integral. What is f2? So in our problem, f2 we have already given here. f2 is equal to sin x. So we shall substitute this. And also capital X is equal to cosecant x. And the value of w is equal to 1. So all these three values now we have to substitute. So here we will be having this to be equal to f2 is sin x divided by w is 1. Capital X is cosecant x dx. Now we have to integrate this. We know that cosecant x is 1 by sin x. So this will be equal to minus integral sin x multiplied with 1 by sin x dx. And so the sin x and sin x gets cancelled, and so this will be equal to negative integral dx. What is integral dx? It is x. So this will be equal to, we have a negative sign here, so it is equal to minus x. So therefore we have obtained the value of P to be equal to negative x. So after finding the value of P, we have to find the value of Q. So the value of Q is equal to integral f1 divided by w multiplied with capital X dx. So this is equal to integral, what is f1? So from our problem, the value of f1 is equal to cos x. So we will substitute that. So the value of f1 is cos x divided by, what is w? It is 1. What is capital X? It is cosecant x dx. So that is equal to integral cos x. Now cosecant x can be written as 1 by sin x dx. So this will be equal to integral cos x by sin x dx. Now what is cos x by sin x? So from trigonometric identity we know that it is cot x, and we have this dx. What is integral cot x dx? So by the trigonometric formula, integral cot x dx is equal to log of sin x. So log of sin x. Therefore, we have evaluated the value of q to be equal to logarithm of sin x. Now after finding the value of p and the value of q, we have to substitute these two values in the particular integral by the method of variation of parameters. The particular integral, it is given by capital P multiplied with f1 plus capital Q multiplied with f2. So we shall substitute all of these now here. So that is equal to, what is capital P? We have evaluated it to be negative x. So minus x multiplied with f1. We know that f1 is cos x plus, because we have it here. So f1 is cos x and f2 is sin x. So we are substituting that. Capital Q is logarithm of sin x. This has to be multiplied with f2. f2 is sin x. So therefore the particular integral we have obtained it to be negative x cos x plus sin x I am writing in the front. So sin x logarithm of sin x. Now, in order to find the general solution, we have to add the complementary function and the particular integral. So, the general solution is given by y is equal to adding the complementary function and the particular integral. So, that is equal to what is the complementary function? So, in our problem, we have got the complementary function to be equal to a cos x plus b sin x. So, let us substitute this complementary function over here. So, a cos x plus b sin x. A cos x plus b sin x. And then we have to add the particular integral. So, it will be negative x cos x plus this we will have to write sin x logarithm of sin x. So now if you see in these two terms, cos x is in common. So if we take that cos x in common, within the bracket we will have a minus x. So a minus x multiplied with cos x. In a similar way, in these two terms, sin x is in common. So if we take sin x in common, we will be having b. So here we have b, and then plus we will have this logarithm of sin x multiplied with the common what we have taken, sin x. So therefore the general solution is given by y equal to a minus x multiplied with cos x plus b plus logarithm of sin x multiplied with sin x. So this gives us the general solution which we have found by using the method of variation of parameters. So as of now, we have completed 3 problems under this topic. Hope you would have been clear with this concept. Thank you.